Hi everyone and welcome to class today. So today I'm going to continue talking about the example that I started last time with the car. And if you remember the ending of the video, I said I was going to introduce the concept of data abstraction and information hiding. So we're going to go ahead and do that. And then from there, I'm just going to talk about encapsulation a little bit more, about kind of like the main parts of object-oriented programming, go back to that polymorphism term from the first lecture, I think it was. And then depending on if we have time or if, I just make it one big video, we might also cover UMLs so that we can just finish like the core class concepts, and then we can move on to inheritance and composition and ideally the next video. And so to save some time, I went ahead and I typed up the example from the board, the light board. And so it might not be the exact same. I tried to make it, but I kind of got rid of things I didn't need. So let's quickly go over that just to refresh our minds. So I did name it car type, and I think it was called car before, but I was like, yeah, I'll call it car type now. And I do have my constructor here. And remember, these are your arguments that the constructor is being passed in. However, the equals 0 means that these are default parameters, meaning that they don't have to be there. These are your initialization of your class variables. Now, already there, I want to clarify something that I don't know if I was clear last time, because I kind of assumed that you might know it. But when you're dealing with a struct or a class, the variables that you're declaring inside of the struct or class belong to that class, and they're only accessible to that class. And so I know I'm going to get to talking about public, protected, private, and information hiding in a bit. But what I'm saying is that each object of the class has its own set of variables, okay? They all share the functions, and by that I'm saying the function is just like an instruction. It's like a recipe, right? It's like if you're baking a cake, and your friend is baking a cake. Each of you may share the same recipe because you found the recipe, you liked it, and you shared it with your friend, or vice versa. But each of you are making the cake with your own set of ingredients. So while both of you might have butter, milk, eggs in the cake, I guess, if you're making a cake like that, then each of you have their own set of eggs. You're not sharing like the same egg because each cake needs its own egg, right? Okay, it's very meta here. But yeah, so that's what I'm saying here. When you're accessing a variable here, that is why you don't need to specify. So when I'm saying max speed here, I don't need to specify whose max speed this is, because it automatically, the compiler knows that it's this object's max speed. So whenever you're creating an object, so when I go here in main and I create a car, so I go and say car type, let's do model 3. When I go and do that, and then I say model 3 dot max speed, and I print that out, which I think should be 0 since that's my default. When I do that, construct here, this is 0. That's coming from somewhere else. But yeah, that 0 right there is from the max speed. That variable max speed is only existing for that specific object called model 3. So if I go here and I say, model Y, I think that's the other Tesla model, I can't remember right now. And then I go out and I also see out that model Y max speed. They might both show 0. In fact, let me just add a line feed right here. I'll explain what that is coming from in a second. These may both say 0, but technically speaking, if I go in here and I increment this, now I'm going to talk about why this is not a good thing, but if I do that, I'll see a 1 for this, but this one's still 0, proving to you that these are independent of each other. And the same thing applies for a struct, which is why I assume for 1 through 5, but let's just make sure that we're all on the same page here, okay? So, yeah, that is also why we don't need to reference specifically whose variable this is, because over here, we're saying this is the model 3's max speed, this is the model Y's max speed, okay? That's the first thing. Going back to this again, this form of initialization with the colon, this is the class variable, and then this is your parameter that you're initializing with. This could be hard-coded, which kind of doesn't make sense why you would do that versus like, setting it equal here to something. But also, you can also put variables which are probably being passed here. So this here is being passed here. Again, this does not cause a problem with naming convention or scopes, because when you're putting in colon, it's expecting class variable names first, and inside of the parentheses, it's expecting something else. in which case it's the closest scope, which is the local function scope, which is going to be your speed. So that's why you don't have any problem there. Okay. I did add this one because I don't think I added that one in the example in the board because it's so small. But I am going to assume that the car, I guess this is a hard coding example of hard coding it to false. I could have done that here, but I wanted to keep them all here. Okay? And then I just added a cout statement inside a constructor that just says constructing car. That's why you guys saw that earlier. But I could do other things here, such as like, you know, I mean, maybe a smart, let's actually do that. So maybe instead of us always just setting this to false, maybe what I want to do is if the speed and the max speed are well, if at least the speed is set to 0, then I'm going to start the car at false. But if for some reason you don't initialize the speed to, if you initialize the speed to anything other than 0, maybe you want to start the car on because it's moving, so it should be kind of on, right? So let's go ahead and quickly add that in. So I'm going to go ahead and just, and again, I do like to keep the code tight. This may not be how you should code it. This is strictly because it's, you know, limited space because I make the font big. So I'm trying to keep the code really tight. It may not be the prettiest, but again, I'm just trying to show you the most amount of code I can in the same page. So that doesn't mean you should be coding like this. Like for example, this really, you know, this should just be 2 lines of code like that. That would look much better. But again, saves 1 line of code, can show more code on the page. Okay. So I could say something like if speed is greater than 0, then I'm going to go ahead and set this on to true. Okay, so now, you know, it gets initialized to false, but then if this also gets initialized to true, I mean to a speed, then this will turn it on. Could I be fancier and put that in here somewhere? I don't think so, because I don't think I can use like a ternary statement in here. But I could definitely get rid of this here and then just put else false. I could also do that if you like it better. So I could say something like else is on is false. Again, you know, you would want to do this in a line like that, but I'm going to keep it all in 1 line. Okay. This could be turned into a ternary statement. So I'll leave that as an exercise for you to do at home. That's a good practice of ternary statements. Okay. So yeah, this curly braces. There we go. Feel better now. Okay. Okay. So the structure again is when it goes out of scope. So I just said it goes out of scope because there's really nothing to do here. Now until we get to the dynamic memory allocation. Here are our class variables. Here's 2 functions, accelerate and brake. This is an inline function because it's being declared and defined inside of the class, you know, blueprint per se. And so all I'm doing is I'm decreasing the speed, but of course you would want to do it more here. Like you want to check the speed is greater than 0. Otherwise, you go into negative speeds, which I guess could work if you want your car to reverse, like in Mario Kart or something. I think in Mario Kart, like you press the brake button. I think if you hold it down after you stop, you start going in reverse, right? Been played in a long time, so I guess that would be that would actually make that do like that. Not a bug, but a feature, I guess. But yeah, okay. I did add some logic code for accelerate just to show you an example of that, and also more importantly to show you an example of defining your function outside of the class. The important thing here is putting your return type, whether it be void or valid returning, or nothing if it was a constructor. Then you put the class name, scope resolution operator, and then the function name, and then your parameters, and then your body of the function. And in this case, I am just saying if the speed is less than the max speed, then it means that we are now at the limit. So that means we can keep going fast, but also check whether or not the car is actually on. And if it's on and we can accelerate further, then let's go ahead and do it. Now this is just accelerating 1 mile per hour up. You know, obviously you would have to call this function repeatedly if you're accelerating. Probably not the most efficient way, but it's okay. If this returns false, I am just defaulting to saying the car is off, which may not be true because it might just be that you've reached the limit of the speed. So this, you know, I would want to add an if statement here that says like if this is what is causing the conditional expression to return false, then actually say it's because you've reached the limit of the speed. Similarly, if it's because it's off, then say that. Here I'm just defaulting to that. So maybe I think a better way would say car is off or max speed is reached. I could do that, but ideally I want to separate that. But again, I'm not doing that because it's besides the point of what I'm trying to show you. Okay. And of course, I'm declaring here an object. I'm instantiating the object, and then I'm just playing with it. Okay. So yeah, this is basically what we coded last time, but now it actually runs, and you can see code runs constructing cars. Notice that when the cars go out of scope, you do get the out of scope message. So you see two constructors because we have two cars, and you see two out of scopes because we have two cars that go out of the scope at the end of main in this case. Okay, so here comes the sort of the cliffhanger that I left you with last time. Okay, right now we have this public key term, which I still haven't fully described how this works. But what I want to point out is a quote-unquote flaw in our car. Okay, not necessarily a flaw, but a risk. If you recall the end of the last video, and you can always just pause this, watch that, and come back, I said that, I was giving an example of the ABS brakes, and I said, it's not always good to give the end user access to everything about your car. Like, sure, they paid not a couple, but, they might have paid several thousands of dollars for them to buy the car. And they own the car, according to, they got a car title, or I guess they're in a loan, whatever. But like the point is that it's their car. So a lot of people will say, it's my car, I should be able to do whatever I want with it, right? And, I'll agree to a certain extent on that. I'm not trying to go into car politics or something. But the point is here that from the manufacturer's point of view, they put themselves in a situation where, like, if the car does something bad, it can come back to them, right? There's things such as recalls and whatnot. So like imagine that somebody crashes the car and the investigators find out it's because the ABS brakes failed. Is that really a problem with the driver, or was that a design flaw? Like, are they liable? Now is the car company liable for that, right? So what does the car company do to avoid that kind of issue? Well, they have an ABS button. They have it on by default. You are able to turn it off. There's an off button in it. However, that's all there's to it. You're not able to access the ABS system and like tweak the parameters that say, okay, probably some sort of sensor that checks whether the wheel is locked. And when it's locked, there's a timer that starts where the brake shuts off per se, or eases off. And then when the wheel is no longer locked, there's a sensor that activates and tries to lock it again, or to apply more brake until it locks and then lets go. Like there's some back and forth going on there, but there's probably some thresholds between the timer, like between sensor checks and things like that, and other fanciness that I don't know about. The point is that that's all code. Okay, that's all programming. Should the end user, who's not a CS person probably, for the majority of us, except us, which we are CS people, but heck, I'm CS people, but I don't know anything about cars. So should I be allowed to go into that computer and play with the variables? That's I guess that's an ethics question, I guess, as long as, and a legal question, right? But what the companies do is they say, no, we're not going to let you. We're going to try to stop you, but it's not going to become like impossible. You can hack in, but you A, lose your warranty, and B, we're no longer liable, because if you hacked into it and you crashed the car, then that's on you, right? And so there is this concept of not just abstraction, but information hiding. The idea being that we want, as developers, for other people to use our code. In fact, it's a really good thing. Like, that means that we're actually doing something good for the world because other people are using the code. However, we can't control everything they do with the code. And because we can't control everything we do with the code, we need to set some limits of what they can and cannot do so that they don't accidentally break the code. Because here's the thing. The person that goes in there and tweaks with the ABS brakes, maybe he had good intentions of trying to improve his ABS brakes, or like, I don't know, improve his miles per gallon or something random, right? It's not like he intentionally it's not like maybe like an assassin hacked the brakes so that he could get the car to crash and kill them and do something, right? I mean, that could happen, don't get me wrong. But I'm saying that's not the reason this is that the manufacturers are doing this. You know, they're doing this with like an honest man's lock, that like there is a difficulty, but it's not particularly impossible to kind of lock somebody out from a system. So as a developer, you are trying to avoid the well-intentioned person from doing something to the code that's going to break it and crash the program. Okay? So going back strictly to talking about programming, that's what you're trying to do. When you're writing a class, and then we are going to talk about inheritance, and we'll expand on this information and abstraction stuff later when we do that too. But you want people to use your code, but you want to limit how they do it so they don't break it. So specifically to this example, think about it. We have accelerate and we have decelerate. So we know that the accelerate function increases the speed, and then the brake function is decelerating, so decreasing the speed and potentially going in reverse, right? Do we really want the user, if they have these functions that are able to do that, do we want the user to actually go in there and be able to change the speed manually? Like, you know, the car's going at 20 miles per hour, but if I go in here right now, as the code is, I can go in here and say something like model 3 dot speed, 2,000 miles per hour, okay? And the code will run. I mean, as long as I put a semicolon. And if I go out and see out the speed of the car, it's going to say it's going at that speed, right? So that may not be good, because A, that's going to break the code now with the max speed. It's like it's useless now. Your max speed variable is useless because the car can go that fast. And furthermore, like with a lot of examples, with a lot of libraries that you use, you can cause problems by fiddling with what would be the internal variables. And so what we ideally want to do is we want to hide certain variables from people using the code or using the library, but still give them full functionality. And the reason we want to do that is to avoid these kind of unexpected errors. We can code error handling. We can code a lot. We can predict a lot of the things the user is going to do, with things, function overloading. We can be flexible and things like that. But ultimately, it's almost impossible to know, given okay, think about back to the car example. Like, you could put all of the safeguards that you can think about in the car, but the one thing you can't just 100% predict is the human factor, right? You don't know what some crazy person is going to do with the car to break every single safeguard that you put in there. Even if they didn't mean to, it just happens. Like, people break things very easily, even when they don't want to do it. So the same thing here. We try to limit it as much as possible so that they can have full usage of this without them breaking it easily. And most people are not going to read the documentation to the code. They're going to just try to use the functions. And so by limiting things and making things private, you stop them from doing that. Okay? So that concept of it's called information hiding. And again, it is the concept of hiding stuff from the user so that they don't break it. The other part of this is data abstraction. So going back to the car example, okay? I just told you a minute ago that I am a CS person, but I'm not a car person. I don't really know much about cars. Does that mean I can't drive a car? No, I can drive a car pretty well. In fact, I think I'm a pretty good driver. So, knock on wood, I don't die driving someday. But ultimately, for me to be able to drive a car, I don't need to be an expert in cars. I don't need to know how an internal combustion engine works. I don't need to know, as you saw, if any of you are car experts and you heard me talking about ABS, you're probably yelling at your keyboard, that's all wrong, right? That's because honestly, I don't know the special technicalities behind an ABS brake. I pretty much don't know anything about cars except how to operate them and maybe how to change the oil, okay? And that's because I don't need to know to be able to use them. Because there is a certain level of abstraction that allows me to use a car without knowing all the intricacies. I know that if I step on this pedal, the accelerate pedal, I don't need to know internally how the pedal communicates with the car and actually, ends in acceleration. The same way, I don't need to know how the brake actually works. I don't even know if there's disc brakes or what kind of brakes they have, or how the brake pedal communicates to the actual braking system. Or if it's a regenerative braking system, how that works. All I need to know is that if I hit the brake button, the car is going to actually brake. Well, it better, otherwise we're in trouble. That is known as abstraction. And the reason that they do that they make it simple is so that people like you and I, who are not car experts, can still use a car effectively and safely. Okay? That's a very powerful concept. And programmers, probably saw cars and were like, well, why don't we kind of apply that same idea to programming, right? Well, I don't know if it came from cars, but the concept is still the same, that they took those ideas of like abstraction and applied it to programming. And that is part of object-oriented programming. The idea that you want to make your classes easy to use by having all of these functions that operate it and not really needing to tell the user how it works. So internally, or externally, I have my accelerate function. And I know that if I call the accelerate function from here, so if I go in here and say model3.accelerate, internally, I could have a million different checks, million different variables being updated, tons of code happening, logic for this to actually happen, whether it be just this example or a real car. But the point is that this accelerate is literally when I'm pushing a pedal. And I could easily program this to a button. So every time I hold down the button, the accelerate function is just repeatedly being called. I can do that. And that's my abstraction. I don't even know internally how this is handled. I don't even know that there's a speed variable, there's a max speed. I don't even know any of that. All I know is that the accelerate function is going to accelerate me, and the brake button or brake function is going to brake me. And that is very powerful because it makes it easy for me to use this. Think back to 135. In fact, don't even have to look very further. Look at the line beneath it. See out model3.maxSpeed and line. If I went and sat you down, obviously I'm expecting most of you to, since you're in Tool 2 that you're learning programming, you don't know much about this yet. But like if I told you what does this do? You would probably tell me something like, well, this prints to the screen whatever it follows. And then what does this do? Well, this prints a line feed and flushes the stdio out. Okay? Cool. All right, that's your abstraction because you know what the end game is. But how does it actually do it? How does this see out symbols, which, by the way, the stream insertion and stream extraction operators, that's what these are called, depending on if you're reading input or writing out or writing output. How does it actually work? How does see out actually work? It turns out that there's a lot of code behind see out, but you don't see that code. You don't even worry about that code. You probably never even thought about that code. Maybe you thought out for 5 seconds and then moved on, right? There's a lot of code that needs to happen for your program to communicate with the operating system, to communicate into the terminal to actually print out text. There's some serious amount of code running there, lots and lots of code, huge amounts of code. But you don't need to know it to be able to effectively use this. That's data abstraction. It's very powerful because it allows you to do a lot without having to know a lot. And so, same thing, airplanes. A pilot knows a lot about airplanes, but he's not an airplane mechanic. He can't go in and change an engine by himself. He's not an AMP, airframe and power plant mechanic, right? So, similarly, an AMP mechanic doesn't know how to fly a plane unless he's actually has a pilot license, right? They need each other, but they don't. But at the same time, each one can do their job without knowing the other person's job. So pilot can fly the plane without knowing the intricacies of the engineering behind the plane, and the engineer can repair the plane without actually needing to know how to fly the plane, right? So that's data abstraction is all over the world, all over the place, and so ultimately, it is meant to make your life easier, and it's one of the most powerful things about object-oriented programming that you want to take advantage of. That you want to make your classes like that. So how do you make classes like that? Let's talk about accessors and getters, which are going to be a very important kind of cornerstone of this. Okay? So when you're writing your object-oriented programming, target classes basically, that you're trying to go with that style, you're not always going to make your variables available to the world. However, you may want to make the variables read-only per se, so a user can read information from a variable, but they can't change it, right? And right now, I still haven't told you public, private, and protected, but I'm trying to hint to you that some of the variables we are going to hide from the user, right? You don't know how to do that yet, you will in a few minutes, but assuming that they are hidden, sometimes you want to hide a variable from being able to be modified, but you still want to be able to look at it. For example, I don't have a speed function in here. Like I have a speed variable, but I don't, you know, if I don't want people to change that variable, then I shouldn't really be able to access it directly. But I still want to be able to maybe read what my current speed is, just not be able to actually modify it. Okay? So what I'm going to do is I'm going to write two functions, or actually I'm going to write, I'm just going to write one function now to be able to read it. And those kind of functions that are able to read information are known as accessor functions. Another name for them are getters. And this comes from because a lot of the times the function name is going to be something like the type of the variable, so whatever the return type is. So like if you're reading an integer variable, so let's just say we have a variable called x, mystery variable x, and we want to get that variable. Okay, we want to access it. So it's going to be a value returning function. You're going to write int, and you're going to write the word get, and then the name of whatever you want to get. So in this case, get x, and then go ahead and just write a very simple function that just says return x. Okay, and this is a class function. All right, so if you're writing this outside the class, then it would be something like, let's say the class is called A, so you would do AA like that. Okay, and somewhere in your class, you would have int get x. That's a function, right, that you're going to define later. So this would actually go above it. But yeah, that's the point. This is known as a getter because you typically put the word get in front, but you don't have to. You can call it whatever you want. It's just traditionally that's what you will see them as, like the word get in front. And these are read-only functions usually, so you don't want to modify it. In fact, a nice little tip for read-only functions that you might see in like skeleton codes and things like that is adding the word const in front of it. So you can actually write the word, I believe it's right here. We'll test it in our code in a minute. You write the word const in there, and now this becomes a read-only function. If you try in here, and I'll show you, to modify x for some reason, like you do this will return to you an error when you try to compile, and it will not compile. It'll say something like, read-only function or const function or something like along those lines. So yes, these are your accessor functions, and then you have your mutator functions. Mutator functions are kind of like the other side of the coin. If you have a variable or set of variables, by the way, usually your accessor functions return to you one variable and your mutators only modify one variable, but you can do whatever you want. You can have it return a list of variables for an accessor function, and for a mutator function you can modify multiple variables at once. It's up to you. It's just traditionally it makes it simple just to do one for each. The mutator functions are also known as the setter functions because a lot of the times the name is the word set and then the variable. So let's say we wanted to modify that x variable again, so this int x. What you would do is you would make a void function and then put set and then the name of the variable. And then in this one, you're going to have a parameter typically, and that parameter is going to be whatever you want to set the variable with. So in here might be something like int and then just some variable name. Make it something different so you don't get confused. So I'm going to say int t. So now I'm going to go ahead and say, actually, you know what would be a nice name for this? Int, like update. So it says updating it or something. So in here, you can go ahead and write x get update. Okay? So this will be a mutator function or a setter function. This is not a constant function, so don't add the constant there because this actually needs to modify a class variable, and it's being modified with whatever the parameter here is. Okay? So that's a setter function. So when you're typically writing functions, they take one of these two roles. They're either accessor functions or they're mutator functions, and they're basically allowing you to have that abstraction. These interact with your internal variables so that you don't show those to the real world. You don't let them play with it and break it. You don't let them tweak the ABS thresholds and make the car crash because they broke the code and now it crashes or something. Oh, now the code crashes, car crashes. Interesting. Okay. So yeah, so let's go ahead and apply this now, this mutator and accessor concept into our program. So we still haven't made the variable private. I still can modify speed, but I'm going to go ahead and add that in. So we already have a mutator function really for the speed, and we have two of them actually. We have accelerator and brake, right? We split it. One of them goes up and down. They're obviously not using the word set because they have a better name, accelerate and brake, but they kind of play the same role of mutators. That's why there's no const. However, we don't really have a way of accessing speed. We do, I mean, right now we do because we can just print out speed, but we're going to be hiding that from the user. So we do want to add a function like that. So let's go ahead and just add a function that is going to be called getSpeed. So speed is a double, so I'm going to make it return a double. I'm going to call getSpeed. I mean, in fact, even a better name would be current speed. That's a cooler name, but I'm going to go with simple, call it getSpeed. No parameters, and I'm going to add that word const because I want to show you how that works. And then I'm just going to make it return the speed. Now you might be like, such a simple function like return speed. Why don't I just access speed? Because we're going to be hiding speed for a minute. Because unfortunately in C++, when a variable is accessible by the user, they can modify it. And you only want them to be able to see it, not to modify it. And you're like, well, why don't you use a const? Well, because a const is going to like permanently make the variable one value. And in this case, we don't want that. We want to be able to play with the variable through our, elaborately, carefully curated functions here. But we don't want to let the user play with them without going through this sort of quote unquote bureaucracy, right? So that's why we want to hide it, but we still want to be able to access it to read it through the getSpeed function, okay? And why do we do this again? Because this part is where we can protect ourselves from getting bad information, like getting bad speed data or trying to make the user accelerate all of a sudden from 0 to 2000 in one go. This is where you can do your error checking and you can sanitize your input. You can do all these things before you let the user modify things internally, okay? That's why like for example, in the string library, a lot of the times when you're doing things in the string library, you're not accessing directly variables. You're calling functions to get stuff that would otherwise, like for example, I know in Python, if you're trying to get the length of a string, you have to use the length function, right? In C++, I think it's also a function, right? It's like .length. Let me see. Let's try it. Let's see. So string a gets hello. A.length. Is that a string or a variable in C++? Returns a number. Sounds like a function. Yeah, function. See, length. So let's just see out that for now. Where are you? Oh, top here. 5. Yep, that sounds about right for 5. So as you can see, this is a function, right? That's your data abstraction. Why don't you just access directly the length variable? Let's see actually if we can do that in that. So I would presume that one of these internal variables, maybe size. That's a function too. Yeah, it doesn't even show it here. There exists somewhere in there a variable. Yeah, these are all functions. Yep, they are all functions. We'd have to see the length function. I used to have when I had actual Visual Studio installed, you could actually click on these things and see the code for the function. I don't think you can do that here. Yeah, go to definition doesn't work. But we could maybe try to I could try to Google it. Implementation in C. I have to find like some documentation. Library function. Let's see if that finds it. I'm getting us a bunch of examples of people like implementing them. GNU.org. Maybe this will give it to us. Nope. Yeah, pretty difficult to find on like the fly, but it's somewhere up there in the internet. Like, try to find it if you're curious. You know, you have to look at actually the header files. Not the header, sorry, the includes, like include string. Actually, oh, maybe let me Google that include string and see if include string library C++. It used to be you would get like one of the first things in C++ or source code. Let's see if that comes up with something. Yeah, here we go. Oh, this is spooky. In here somewhere is the actual code. Let's try to write the words. Let's see. That's a very generic search term. Nope. Let's try to just look at something. Okay. Nope, that's not related. I was just trying to see if I can get into some code so I could play around, so I can move around with it. Binaries. No. Yeah. This. All right. Well, I think you can find it through here. So check out this website, gcc.gnu.org, and you can try to find the source code. I wish I could, you know, I could do that still. Like, it would be cool. Like, if you're running a debugger, you would actually maybe. Let's see if it'll. Maybe if I get lucky with this. Nope. No. Yeah. Back in Visual Studio, like actual Visual Studio, if I actually went into the function with the debugger, it would actually show me the source code for the function. So sad times. But anyways, take my word that these functions are pretty intricate, and you don't need to worry about that because of data abstraction. Okay. So yeah. So now that we have our getSpeed function, we can actually not refer to the variable manually. We can just call the functions. So like, after I accelerate the car, let's try to get the speed. So I can just say model3.getSpeed. So really, you know, when you're doing object-oriented programming, you really should only be interacting with functions and never with directly with variables. Like that's like 99.9% of the time. That's what you should be trying to do. As you can see here, let's see. Oh, car is off. So when I try to accelerate, the car was off. So we need to turn the car on. So that's, you know, we could leave that accessible to the user, but again, let's take the object-oriented programming approach and write accessors and mutators for that. So I'm going to write a function called void. I'm going to call it turn on car, or just turn on. And all I'm going to do is set is on to true. Actually, so I don't have to write a turn off function. I'm just going to call it toggle car. And I'm just going to set it to whatever the opposite of what it is currently. Okay. Semicolon. So that way I can just toggle the car. Model3.toggle car. So that turns on the car. Or off, but in this case it's me not on. So now when it accelerates, it's still 0. Let's make sure that, sorry, I have this because I have to see out it. Otherwise I can't see it. Speed 0. Model 3 toggle car. Maybe it was already on and I turned it off. Let's try that then. Nope. Why is it not doing that? Let's go run through the debugger and see. Start debugging. So let's see, toggle car. So we go into that function, accelerate. All right, so let's see what the local variables say. Speed is currently 0. Is on is true, so the car is on. Oh, the max speed is 0. So it's, you know, my max speed is 0, so it's always going to like stay to 0. So actually, I shouldn't have set this as a default to 0. I forgot. I think in the board I put in 120 here, right? So my bad. See, debuggers. Debuggers are your friend. See how easy that was to see the problem instead of staring at code and hoping for like divine intervention. So yeah, so now if I go to toggle car, you know, it turns it on. Let's see, so we have Model 3 and Model Y. Model 3's speed is 0, it's on. Model Y is off. But they both have a max speed of 120 now, so it should be okay now. So if I go and accelerate, it goes through the if statement. It's good. Here we'll see it update 1. See, the speed is 1 now. So now when we print it, we see speed 1. So yeah, it's working now. Thank you, debugger, for fixing our code live. Okay, so yeah. Now the question is, okay, we understand that we want to do abstraction. We don't want to, you know, access variables directly, but how do we stop them? Because right now I can still type in very easily here and break the entire thing and go in and say like, yeah, I'm gonna put in model 3 dot speed over 9,000, and like if I run it, let's run. Now I got like 9,001 speed. Yeah, it's not going to 9,002 because of course the accelerator is like, yeah, we're already at the speed limit here. So yeah, how do we actually stop that? Before I show you very fast, I do want to show you something. The get speed is a constant function, right? Let me just show you that it actually does work. Let me try to change the speed here in the read-only function. Let me just I don't know, do speed equals or speed plus plus. Okay? Just say that you accidentally did that in when you intended to be a read-only function. This is really good because already you can see it's underlining it, but like let's run it and see what happens. Okay, I think it must have not compiled. Yeah, but it still just gave me the previous output. This is better seen in the terminal. But I mean, this is the error, but let me just show it to you in the terminal. G++. I'll move the terminal in a second. Undefined reference to main. Okay. Oh, that's right. Yeah, my bad. That's because this is not that code. This code is somewhere else. Open new window. This is actually... Let me just give me a second to see where this is at. Okay. Okay. So I think it's here. Let me just take a look at this file. Yep, okay, this looks right. So I was just trying to identify where that C++ file was at, and it's right here. So there we go. I'll leave that open in case we need to use it again. So now G++, main is called main.cpp. There we go. Okay, so this is the error that we get. So in member function double card type, by the way, the word member function is because this is a function that's part of a class. Const error increment member card type speed in read-only object. So this is the error you get when you try to modify a variable inside a function that has the word const on it. So this is strictly something to protect you again, or protect you from the user doing something they shouldn't, but also from you accidentally when you're typing your own code to not do something bad. Actually, I think that's actually better reason for it, because you're actually writing the function yourself usually. So you're writing a function yourself, and you know this is supposed to be a read-only function. By you putting this at the beginning when you're starting to write the code, you avoid accidentally doing this at some point, because it'll give you an error. And trust me, it is much better to get a compilation error now than it is to actually not notice that this should, you know, because if I remove this, this will compile and run just fine. But then like you'll notice your speed is always like off by 1 every time that you want to see the speed, and you're like, oh, that's weird. And then, you know, again, you have to run a debugger to find out what happened, or stare at your code for hours. So don't ask me how this would get there, but it probably, you know, accidental copy pasting, you never know. how bugs. If we knew, then they would never happen, right? We would never have bugs, so we never know. So yeah, that's a very useful thing. It's a nice little practice that you want to get used to, spreading cons. But yeah, okay. So I just wanted to show you that before I forgot. But going back, how do we make this variable hidden or inaccessible from the user so that they can't just do speed? And also max speed is in the same world and is on. So we want to make all three hidden. Well, let me just show you very quickly how to do it. And then you'll be like, okay, very cool. That was easy. So first of all, I'm going to go ahead and move this to the bottom. It doesn't have to be in the bottom, but just for now. The ordering doesn't matter, by the way, of the functions here and the variable declarations. Like, they don't really matter. I mean, yeah, I would say they don't matter. Like, there might be a tiny difference in how things are stored in memory, which we'll talk about in the future. In fact, trying to hack into private variables, it actually matters there. But for now, just don't worry about it. Just put the functions in any order you want. Maybe choose the ordering that makes it easy for you. I would recommend you write your functions first and then your variables. I don't know why. That's what I always do, and I like it, so that's why I'm recommending it. So, yep, nothing more to say there. Okay. So yeah, okay. So now we have at the bottom. Here's what I'm going to do. Instead, you notice I have this public word here now. We can finally talk about how these things work. Public is whenever you're putting in a member of your class, whether it be a function or a variable, you have to tell it whether it is a private, a protected, or a public member. By default, all classes in C++ are private. Or sorry, all members of the class are private. So if I don't put anything here, this automatically says that everything beneath that is private. The act of me writing the word public here is telling the compiler that no, these are not private, these are public. What does that mean? Okay, the three words, public, protected, and private, right now I'm going to just focus on talking about public and private, but we will revisit protected when we talk about inheritance. So really what we need is a chart. Data abstraction, information hiding. Okay, just wanted to write those terms out. Hold on. There we go. Okay, so for now, I'm going to go ahead and write the word public. And then I'm going to write the word protected, but we're going to leave this section like incomplete for now, and then revisit it in the next lectures when we talk about inheritance. Okay. And so there are different scopes that you have to deal with when working with classes. You have the scope that is inside of the class, you have the scope outside of the class, and then you have this third category, which is a derived class, which again is what we will talk about when we talk about inheritance. So for now, we're going to leave this derived section kind of empty. And we're really going to focus only on, actually, 4 squares for now. These 4 squares, okay? So those are the 4 squares that we're going to be talking about today. And then the other 5 squares we will talk about after we talk about inheritance, okay? So we have inside of a class, and then we have outside of the class. What this chart is telling us is where can I actually access a variable? And if I can access it, I can modify it. So where can I do that? Well, when something's public, then you can access it anywhere that you actually have it in that scope. So a public variable, by default, there is accessible inside and outside the class, and that's exactly what we've been doing so far. And that's how structs work too. By writing the word public here, these functions, these variables are accessible. Now, I do need to have the object, so I need to have an actual object of car to be able to access them, because it needs to know which objects, like again, it's like, I can access the cooking ingredients of the cake. I can access the egg and the flour and all of that, but I need to know whose cake. Is it yours or your friend or your friends? Like which cake am I accessing, right? So as long as you tell it which cake you're accessing, you can access all the ingredients you want. You can access the speed of any car as long as you know which car speed you're accessing. So you do need that actual, link to the object. But once you have that link, if something is public, you can access the functions or the variables that are public without any limitations. If it's public. If it's private, then you can't access it. So if I go in and I switch this to private here at the top by just removing it, first of all, if I try to compile it, I'm going to get like 50,000 errors because the constructor has to be public. But for now, I'm going to just do it with the variables. I'm going to go ahead and write the word private here. Again, by default, classes are private, but you can also manually say private. You can also switch back and forth, as I'm doing technically here. At the top, I have a bunch of stuff that's public, and then I have a bunch of stuff that's private. But I could just as easily switch back and forth, like I said. I could write the word public again here. In fact, I could write the word private there again, but that'd be kind of weird because I already did it. So yeah, I could just go back and forth as much as I want between public and private. Again, organization for me is I write all my functions and all my variables. So I'll write all my public functions first, then all my private functions, then all my public variables, then all my private variables. That's what I prefer to do. I believe you're free to do whatever you want within whatever code grade lets you, and so on. Whatever your grading requirements are. Okay, so by doing this now, I am now in the private category, the bottom two squares. So what those two squares do is basically telling you where you can access now the variables. Now, I actually cannot access it outside of the class. So what that's saying is that you'll see it here being underlined. Anytime that I try to access this variable that is part of this class, I'm going to get an error. Let's look at those errors actually. In function main tells you the line number and the character number. Error. Double car time speed is private within this context. Context basically referring to that, where you are in the code and the scope. And then it gives you the line. Note, declare private here, line 20. So when you declare the variable there, because it had the private thing on top of it, it's saying, yeah, this variable is private, but you're trying to access it outside the class. That's a no-go. Same thing with the other speed line of code that's referring to speed. So you cannot access private variables outside of a class. You can, however, access them inside of the class. What does that mean? That means that the code that we also have here, like, accelerate function, where we're actually accelerating the speed, or in the break function that's in here, where we're just, or get speed, which we're just returning the speed. So all these functions are members of the class. They can access it. Think of it like a house. The class is a house. People that live in the house, that are members of the household, they can access everything inside of the household, be private or not. But members from outside the household cannot access the stuff inside the house, like it's private. They need permission. They will have to be public, or they have to be friends, which we'll talk about when we talk about friend functions like a while from now. When we talk about operator overloading and stuff, that's going to be like week 10 or something. So whatever, check the calendar. But yeah, it's a while from now. So yeah, outside of that scenario, with friend functions, only the members are allowed. It's like you're a part of the club. You can only, if you're in the club, then you can access the private stuff. Otherwise, you have to ask someone that's in the club to give you access. And that's what this is. Your accessor functions are like the club members that let you in there. Like, well, they not let you in, but like give you access to them. So they're like the messengers. So I used to give an example in my previous videos, and you're always welcome to. I have at least three semesters that I've taught 202 online. One of them was summer, and the two are regular semesters of lectures. And you're more than welcome to check those out for further examples. That's usually the main thing, but also just, me saying the same thing in different ways. Obviously, it's kind of hard to say the exact same thing with the same example. So it varies. I think I have used the car example at some point though, I feel, but it wasn't anywhere like this at all. So ultimately, No, it's a good reference to check that as a review. But basically, in one of the videos in the past, I used to say it was a castle, and like, you know, you can think of it like the castle, you know, private variables, they live in the castle, and if you want to access them, you have to get the messenger. So the messenger has to come out of the castle, get your message, whether it be you want to see a variable information or you want to modify the variable, and then the messenger brings it in. But the messenger can control what he accepts and doesn't accept, right? So you don't give it invalid data. And so that's kind of what the accessor and mutators are for. They're the messengers that allow you to access that private information. So get speed is the messenger. In this case, it's just a messenger that allows you to see what the speed is, but you can't modify it. If you want to modify the speed, you have to talk to the accelerate or break functions, which will, you know, if we finish implementing them properly, will only change the speed if you meet certain parameters, such as the car being on, the speed within the tolerable range of the max speed, and then the brake not going, unless you want to, going negative. But even if you go negative, you probably want to set a max, like reversing speed, right? So, you know, that's still something you want to throw in there. Probably another private variable. And maybe that one's a constant and you always just hard code it to, like, I don't know, 40 miles per hour reverse. That's still scary fast for reversing. I don't know how fast cars go in reverse. Yeah, 40, I think they could reach 40, but I don't know. No idea. Never reversed that fast before. Don't try it at home, I guess. But if you do, let me know. Okay. All right. So, yeah, that is your private. So now by making it private here, I can no longer access it. And that's good because you'll get errors. And that, you know, it's the same thing with when you're doing autocomplete and things like the library function, you usually don't see them because of that, or you just get an error. But like here, I still see them, I think. No, actually, I don't see it anymore. See that? I don't see them. I just see the functions that are public. That's pretty cool. That's probably why I didn't see the variables with the string function. Whereas if I comment this out, then the autocomplete will actually show me the variables there because they're public. Okay. By the way, if you want to see a debugger video, if you're not comfortable with debuggers, you can check out the first lecture of fall 2021. I believe that I had a full video on installing a debugger. I'll try to leave a link on the description below, and maybe on Canvas as well. Just there's no point in me redoing that again, since I've already gone over it in the past. So, and it's something that really should teach in 135. Like, I don't get why. Or you should just pick up on your own. Like, don't ever just debug code without debuggers. It's not good. I want to say insulting words, but no, I won't say that. But it's just not good. Okay? It's foolish, I say. Okay. So inside of the class, you can access things. Outside of the class, you cannot. So that is your differences. For now, even though I really haven't talked about much about protected, for now, when you're just dealing with, we're not dealing with inheritance, it just turns out that it works the same way as private. So inside of the class, you can access it. Outside of the class, you cannot access it. So when it comes to just protected right now, if you were to use it, it would actually have the same end result. But again, why does it exist then? That's because when it comes to inheritance, it will actually have an important difference. So if I go ahead and do protected here, it's the exact same thing. There's no difference between that and private at this point. But again, I'm going to revisit that when I do talk about inheritance. Okay, so let me just check now to see if there's anything else I want to say. Nope, that's it. That's all about public and protected. You know, just think about it. Do you want somebody to access this variable? If they do, that means that they can put whatever they want. They can throw in negative numbers, they can throw in positive numbers, they can throw in like 0, things that potentially could overflow. Like, just remember, every time you give access to a variable because it's not private, they can do anything at any time with it. And by the way, it's not just variables that you want to make private. Functions can also be made private and should be made private, certain functions. Sometimes you want to have an external function that, again, is that messenger function. But internally, you might want to have like intricate functions that allow you to do things that the external functions like, share in common. For example, you might have a really nice function that can like find out the simple example, like the average of something, right? And that average may be used by multiple functions. That's okay. Make that a private function because maybe you don't want the user to see that average, and then just like have that called out. When we talk about recursion, you could make your internal functions recursive, but the external ones not be recursive. A lot of things you can do, a lot of reasons to make functions private, and you should just remember that they are, in that case, really meant to be internal only and not for external use. Okay? Maybe because of some of the parameters they take are actually parameters that you don't want the user to have access to, so they have to be done internally, and they just get called by the function that the user is calling. So the messenger calls the other functions, okay? So, and if I think of something else, I'll include it in another lecture, but I think that's pretty much an exhaustive version of that. Okay, so let's go back. I don't remember if I defined this term. I know I mentioned it last time, which is why I'm going to define it again. If I already did, I apologize. And that's encapsulation. So the sort of cornerstone of object-oriented programming is that we are basically making these objects that are taking all of the data and the operations on that data and then putting it all in a nice, well-packaged form, little bucket that does everything, right? In this case, our car, we have all the telemetry of the car, the speed and whatnot is the data. And then the operations on that, which are things to change the data, such as accelerate, decelerate, give computation of the data, etc., etc. It's all connected in nice package. It's all well contained. Think about in 135 when you're coding without this concept. You do everything in the global scope. You're writing a bunch of global functions, which is just a function, which you pretty much all your functions in 135 unless you made some inside of a struct or global. You don't do a lot of global variables in 135 because they discourage you from that. And why do they do that? Why do they discourage you from that? Well, they say if you're working as part of a team and you write a global variable, everybody can access it and nobody can use the same variable name because like you're taking it. So if you write a function called print that's just printing something, nobody else can write a function called print because they would have to either overload the function and then you have to be careful how you're doing that because you might not break their function and that might not. It's not a good practice, right? So object-oriented programming solves that issue because when you create a class, sure, the class is global, although you don't have to, I guess, in theory, make a class global. You could actually declare a class inside of a function. It would only work inside that function, which is kind of weird. So that's why you don't really see that often. But you can do it, definitely can. In fact, I'm pretty sure you can write a function inside a function. Again, that function would only work inside the other function, which again is like why, but you can do it. So, yeah, let's see. I know you can do the class one, but the function one I want to triple check. So let's just randomly inside of the accelerate function, let's just write a void foo. Don't let your memes be dreams. Write a function inside a function. Function inception. I think that's it. Let's see if it doesn't yell at us. It doesn't. Ooh, it didn't work. No, so it doesn't allow us. Okay, I take that back then. But you can write a class or a struct. That one I do know for sure. So I can write a struct. Actually, oh wait. Maybe this is not letting us because it's a. Oh no, it did let us. Okay, so inside the struct now, I can write a function. There we go. So I don't take it back. You just have to put it inside a class. So now I have kind of class inception. I have a class, and inside of that class, there's a function. And inside of that function, there's another class. Well, I guess it's a struct, not a class. And inside of that struct, there's the function foo. However, this function foo and this struct A can only be used here. So I can make objects here. I can say like AA, and then I can say like A.foo. I can do that here, but like, I can't do that like in main. I can't say AA in main because it doesn't exist. It will give me an error saying like, what's A? I don't know what this A is. A was not declared in the scope, see? However, right now, I did it, see? So you can't write functions inside of functions, you just have to put them inside of a struct. Little asterisk there, okay? Obviously, you don't typically do this because like I said, you only really get to use that struct in this line, in this space of code. So like, you know, I mean, I'm sure there's like one place when you're writing one version of the code, you're writing like a really big function and you really want to use a struct in there, but like, and you don't want to like litter the global scope with that struct. That, you know, this could be okay, but I would say the majority of the time it's just unnecessary. I'm gonna leave it there because why not? I'm just gonna comment this out. But yeah, that is a little bit of exaggeration, but that is your concept of encapsulation, and that is the idea of basically taking everything together and pre-packaging it so that it doesn't mess with other people. Because now your class, you can have all the variables that you want, you can access them with functions, be very happy, but not mess with the global scope. So other people who are working on the same code base don't have problems with you, as long as they don't make another class called car type. And actually, it's cool because like a lot of the times in 135, when you're programming, like, you know, it's hard to keep track of like parameters being passed, right? And functions, right? Like, you know, you write a function, you got to pass in like 50 parameters into the function. Like, you know, let's say you're trying to compute like some rocket trajectory and you need like 50 different variables and you have to organize the variables and it's a pain. Like, it's just not cool. You're like, man, I wish they were all global variables because then I just can reference them by name. Well, guess what? If you're doing a class, you're basically doing it as if it was global variables. You just put it inside of the class. And now you want to access the variable, you don't need to pass it a function parameter because all functions have access to all the member variables directly, right? Like, I don't need special code to be able to access like the max speed or the speed variable from inside the accelerate function. They're members of the function, so they are able to access any variable, right? Private or protected or public. And so that's really cool. Look how nice this is. Like, to be able to write this code, I don't need to pass any parameters. The only parameters you usually pass here are things that I'm reading in from like main in setters, right? Like, for example, actually I don't even have it anywhere here, right? Yeah, there's no functions like that. But if I wanted to have a function that's called set max speed, then I could do that. So very quickly, just throw one in. So void set max speed. So I'm going to pass in a parameter int for that, m for max speed, and then I can say max speed. Well, I can do some parsing. So for example, I can say if m is less than 0, then set it to 0. That way I don't pass a negative max speed. So here I'm doing, see, this is why this is better than giving public access to the variable, because now you can sanitize whatever weird things the user puts. They may not intend to put a negative number in there, but they could have accidentally done it. So you can clean that out here, not letting them put any negative numbers. You could do some hard limits like, you know, if m is greater than 9001, then you're like, that's the limit. I'm not gonna let them do any bigger thing than that. So I'm gonna set that there. So that, like, no matter what code they write, I will never let them have a number bigger than 9001 as the max speed, because that would, like, maybe you put the speed of light there, because you're not allowing cars to go faster than the speed of light, because that breaks physics or something. I mean, pretty cool. Okay, and then at the end of all of that, you can say max speed gets m. Okay, so you're sanitizing your input and then you're actually setting it. So that's actually a pretty good use of that. You still are giving the user an ability to set the max speed of the car after they created the car, but within certain extents. The same kind of checks you would want to do here for the max speed on the constructor, because right now all we're doing is we're saying, well, if I don't give a max speed, we'll put 120. But right now, because the user could pass in like a negative 200 here, and it would be okay. So in the constructor, you may want to actually defer setting the max speed to a function. How would I do that? It's actually a good example. Let's do that really quickly. Let's get rid of this. And now here, let's go ahead and call the max speed function. So set max speed and then pass in, what is it, m. And now I don't have to copy and paste code, because otherwise I have to copy and paste the same checks. I can just, from my constructor, call one of my functions, which already has all the checks I need to do, and just let it be. So that's convenient, actually. It's pretty neat. So yeah, saves you time and saves your code. You only do the checks once, and then you can actually refer to that function here. And again, the only parameter stuff, very minimal, because everything I can access thanks to it being a member variable. So if you thought that not being able to use global variables in 135 was limiting you. Well, guess what? With classes, that limit is removed for the most part, because you still shouldn't use global variables. Don't get me wrong. But I'm saying they work like global variables within the class context when you're creating variables. You don't have to worry about parameters and stuff. So it's very, very nice. So all this concept of keeping everything tracked is encapsulation. So now we can actually go back and visit sort of the little triforce symbol that I drew on the whiteboard today. So we can revisit what object-oriented programming, the cornerstones of that are. And those are going to be encapsulation, very powerful. We have abstraction, the data abstraction and information hiding. So encapsulation keeps everything nice and well contained, makes it easy to develop code, makes it easy to port that code elsewhere. And when we get to inheritance, it'll make it easy for that too. Abstraction makes it easy both for you to develop and other people to use, but also it just makes it so much simpler to keep the code safe by doing the information hiding and not having to do as much sort of debugging code or error checking, because you limit what the user can input, so you don't have to do 50 different locations of error handling. It's like if there's only one way into your code, then you can do all the checks there, so that there's no other way they can break the code. It's like imagine that you have the castle, and you only have one way in. You can do all the safety checks you can in that one way in, because you know that's the only way they can go in. Otherwise, if they could go in from anywhere, then you have to do the checks everywhere. So, that's that. Okay. And finally, the other big concept, and that's the one that we only just kind of touched on the other day, is polymorphism. We touched on compile time polymorphism, but there's a lot more to it. We're really going to revisit that when we talk about virtual functions and templates. So for now, it's the flexibility of that your class can just do much more and take much more shape than what you initially thought. So really, this is going to be your cornerstones of what object-oriented programming is. I don't know if circles are the rest. Let's go with the triangle. Like that, okay? There is one more sort of point to this, and that's going to be inheritance. So that's going to be the fourth thing that is to be added. But for that, I'm afraid you're going to have to watch the next video. So I will leave you with that cliffhanger there. Okay, for the last thing that I want to show you on today's video, and I know we are getting close to running out of time, but don't worry. Last week we had shorter videos, so next Tuesday, is the UML. The UML is just something very brief. In fact, I'm just going to go ahead and paste a couple of pictures to save some time from another lecture. I believe this is last semester's lecture. So what does UML stand for? UML is the Unified Modeling Language, and it's just a way to easily convey your sort of class to other people without necessarily linking it to C++, and also just to keep it very compact. So like, if I tell you I would like you to develop a class that does this, this, and this, without writing you the code, I can just give you this, and then you should be able to implement it pretty quickly. I don't know if any of the assignments will use the UML, but if they do, that's why I want to show it to you so that you can easily understand the assignment. Okay? So a couple of things in the UML are going to be the symbols, the plus and the minus. Plus is public, minus is private. And the way it works is it's a little sort of square or triangle or rectangle, I guess, that has on the top the name of the class, which in this case is triangle. That's actually the name of the class here, triangle. And then what you're going to do here is you're going to list in the first sort of sub box of this is all of the variables in that class. And in the second sub box, you're going to list all of the functions in that class. For the variables, the first thing you're going to do is you're going to put a plus or a minus. Again, that represents whether the variable is public or protected or private. So a minus is private. So say in this case, I'm saying that all of these variables are private. Now, what is this doing? This class is representing a triangle, okay? So we have two dimensions that are important in the triangle, which are the length and the height. But also we have a color of the triangle, because I guess we want a color. I think the reason why I did that is because I just wanted something other than a numerical value. So I said, hey, colors, it's a string. So yeah, okay? So we're making all of them private. Again, because of data abstraction, the majority, if not all of your variables will always be private in a class, because that's the whole point. Okay. As for functions, we do have 2 public functions. We could have had a lot more, but again, I just probably was just, I wanted to be very brief of how this works. What you're going to do for that, actually, wait, no, let me go back. Sorry, I skipped. So after you do public or private, in this with the plus or minus, the next thing you need to put in there is what you want the variable name to be. So in this case, we have the variable color. For height, I just went ahead and put an H, and for length, I put an L, but whatever variable names you want. And then you just put a colons. Don't worry, that's just part of the syntax of the UMLs. And the next thing you see is the type of the variable. So if it's a string, if it's an integer, when we talk about inheritance and composition, it might turn out that you could actually have classes within classes. Not what I showed today, but similar, but not quite. So this is whatever the data type is. It may be whatever. It doesn't have to be a built-in data type. Okay? We'll come back to this when we see that, and we'll update our UMLs. That's it for variables. And then for functions, you put the function name, you put the parameters if there's any. If there's none, you just put the parentheses, just like if you're writing your function in C++. Again, the colons, these colons do not have anything to do with the colons with the constructors. It's just coincidence. And then the return type of the function. So this is a value returning function that returns a string, and this is a void function that is just a setter, right? So here's a getter and a setter, and that's it. If you're trying to write a constructor, then you can just do that. Let's make a constructor right now. So we're going to say triangle. Let's just not put any parameters. And then that's it. Nothing. You don't put anything in there because the constructors don't have return type, right? So yeah, I mean, if you want to write the word constructor in there, it'd be my guess, but it's kind of understood. So yeah, I mean, it's pretty straightforward how to see these UMLs, but I wanted to point them out just so you don't get lost if you see any. So again, quick overview again. This is the class name. These are your variables. These are your functions. The minus means private. The plus means public. These are the variable names. These are the function names. These are the variable types. And then these are the function return types. And then in here you have your parameters. Const int ampersand means that this is a read-only parameter. The reason why you would do something like this is because remember your 135 pass by reference and pass by value. Normally when I've been doing all the parameters today, I've been passing by value, which is making a copy of the variable. That is not the most efficient way to do it because you have to actually copy the variable. Sometimes, especially if you're passing in something big, you want to pass a reference of it only. And so how do you do that? You put an ampersand. So now you're passing a reference. But by passing a reference, that means that if you accidentally modify that code, or sorry, that variable in the function, then you're going to be changing the original one, which may not be a good thing. So just like you protect yourself in read-only functions in C++, you can protect yourself. And by the way, you could do that here too. If you want to make this, if you want to protect yourself here, you could put that const symbol here. Just make it a read-only function, right, for that one. But going back to the set one, if you want to protect a variable from being modified accidentally, you write the word const in front of it. So you put that in here, then you put your int or whatever the type is and your ampersand. And now, if you accidentally try to modify this variable name, obviously you need if you're writing the function, you need to put in like x, y, whatever the variable name is, right? But if in the function you try to say something like x equals 5, this const will give you an error, okay? So let me show you that actually really fast. So let's go ahead and, yeah, we have a set max speed. This will work. Oh yeah, perfect. So the way we have it right now is we're actually passing this by value, right? Because I'm actually playing with the m before I actually set it. But let's say I wanted to pass it by reference. If I did that, then anytime I'm calling it, I'm going to actually modify it, which is not a good thing. So like, if I call, let's make a variable int new max. Let's call that 100, and then I'm going to say model 3.set max speed m, or new m, sorry, new max. Okay. Now if I go ahead and say model 3.get speed, and I see out that, why is it that color? Did I forget something? Oh no, I just, there we go. Okay, and then I go ahead and also see new max. Let me just call it speed, new speed. All right. Sorry, do we have a get max speed function? I don't think we have a get max speed function now that I realize it. We need a get max speed function just so we can see this. Let me just run really fast. Int get, I'm just gonna call it get max speed. Return max speed. There we go. Okay, so now we can actually return the get max speed here. So, oops. Get max speed. And you see, very cool. Okay, and then I want to see new max again. So new max. Now it's going to print out the new variable. I want to show you that that variable is being modified as it is right now. Well, not always, but sometimes it gets modified. So right now, if we run this, we can see. Oh, hold on, I got some errors. Oh, that's because I already made it by reference. Let me switch it back to not be by reference. So make it by value. So make it how we had it before, and then we don't have any problems. So you can see that, let me add some line feeds to this. Okay, so you can see that our new max speed is now 100 and new max is still 100, right? So everything is okay here because we're passing by value. The problem comes in if we try to pass by reference. Now, why are we doing that? Why do we want to do that? Because like it's faster that way. We don't have to make a copy. We're just passing a pointer. For something like an integer, actually, it's probably not faster. But if when we learn about like passing an entire class in a function, and that class could have like 1,000 variables, that can actually be like a burden. So like we don't want to do that. We want to pass by reference. So let's try that. Let's try passing by reference. Now you're going to see some other errors because of some of the code that I have up there. But yeah, if I switch this to reference now, first of all, I'm going to get, it's going to yell at me here because this could be a constant value. So it's like, yeah, don't do this. So for now, I'm going to just comment this out. We'll come back and uncomment it once I do the fix that I want to show you. But yeah, so now this works. But the problem we're going to run into here is that, right now it looks like it's still working fine. Like you're like, okay, new max speed and new max is still 100. But if I try to make this new max be, I don't know, what was it, like 10,000? 1, 2, 3. You can see that new max is limited to what we set the hard code. 9001 is the most max you can set it. But my new max got modified, right? Like my actual variable got modified, and that's not a good thing. You don't want to do that because like if somebody doesn't know this and like they modify a variable that they're using, this could create a bug if they're using this variable elsewhere. So you don't want to do that. So what could I do if I were to leave it like this? Well, I could create a new variable and then modify that variable. Or I could, but you're not going to get the warning. How you get the warning is you can put the word const. Now it's by reference, but it's going to warn you if you try to modify it. It's going to be like, yo, you're trying to modify a value that's supposed to be read-only. And so you get that warning and you're like, oh, okay, now I can handle it. So how can I work around this really fast? I'm just going to call this int m, let's call this one m2. Just get int m gets m2. Now I'm working with a copy, so I should be okay. All right, and now we can actually go back and uncomment this, and it should still be okay because it's a const. Before, it's yelling at us because we're passing by reference, but if this is not a reference, if this is not a variable, but it's like a constant because it was hard coded because you didn't pass in the value in. That's what that error is telling you, because like bad things can happen if you try to modify read-only memory. So like, yeah, it's like, no, don't do that. But yeah, so that's how the const works. It's another thing to protect yourself so you don't make mistakes later, as long as you remember to do that in the first place. It's good practice to do that stuff. Okay? So, all right. Now that's really all I have. Okay, so in summary, today I implemented the code that we talked about last time. We got to further explore things like encapsulation, data abstraction, and just you know, the different kind of tips that you got, such as read-only stuff using const for both variables and functions, and UMLs you also talked about today. And ultimately now you know how to code classes. You're prepared to go out there and code classes. Is there a lot of other little weird things about classes that we're going to learn as we go along? Absolutely, particularly when we visit virtuals. But the biggest thing next being inheritance. So it's not the end of classes. Classes are going to basically be that building block of the rest of the course, aside from when we talk about things like pointers. But even then, once we get to pointers for classes, we'll use classes. So like, they're not going anywhere. So even if right now you're still not like 100% on classes, just go out there and start coding some classes and watch my old class videos. And I think, you know, as we practice, you'll get better at it. Okay? So without further ado, I'm going to end the video before I go any further. So I thank you all for watching, and stay tuned for next time. Take care.